Hello everyone. In this lecture, I am going to discuss about concept of activation energy and its calculation from Arrhenius equation or temperature dependence of reaction rates, Arrhenius equation and activation energy. First of all, I am going to discuss what is activation energy and how it is calculated by using the Arrhenius equation. In 1889, Arrhenius gave the quantitative relationship between temperature and the rate constant and hence the rate of a reaction. The expression is called Arrhenius equation and is written as K is equal to AE minus EA upon RT, where A is a constant called frequency factor or pre-exponential factor because it comes prior to exponential factor. It gives the frequency of collision of reacting molecules. When reaction takes place, the reacting molecules collide with each other and how much frequency they collide with one another is given by frequency factor. EA is called energy of activation. R is a gas constant and T is absolute temperature. The exponential factor E minus EA upon RT gives the fraction of molecules having energy equal to or greater than activation energy EA. The activation energy represents the minimum energy that the reacting molecules must possess before undergoing a reaction. Let us take this graph to understand only what is activation energy. These are the reactant molecules. They have their own energy. On y-axis we have energy and on x-axis we have reaction coordinate. So for conversion of this reactant into product, it needs energy called activation energy. This is activation energy. So when reactant molecules collide, they attain their energy equal to or greater than activation energy and then gets converted into product. All the molecules do not attain the energy equal to or greater than activation energy. Only fractional molecules attain energy equal to or greater than activation energy and they get converted into the product. So activation energy is the minimum energy that the reacting molecules must possess before undergoing a reaction. Without attaining this activation energy, the reactant do not get converted into products. So they need a minimum energy called activation energy. Taking logarithm on both sides of equation 1, we get log of k is equal to log of AE minus E upon RT. Log of k is equal to, this term become log of m into n because it is product of two terms and product of two term is given by log of m plus log of n, means log of a plus log of e raised power minus ea upon RT. Log of k is equal to log of a minus ea upon RT. Now, if K1 and K2 are rate constant for the reaction at two different temperatures T1 and T2 respectively, then log of K1 is equal to log of A minus E upon RT1 and for rate constant 2 it becomes log of K2 is equal to log of A minus E upon RT2. Now subtract equation 3rd from equation 4. Then we get log of K2 minus log of K1 and this get cancelled by this. So we get minus EA upon RT2 minus EA upon RT1. This minus minus become plus. So we write this term firstly. So it become EA upon RT1 minus EA upon RT2. Now this is log of K2 minus K1. It becomes log of K2 upon K1 is equal to EA upon R. Take this EA upon R common and uh, in bracket remaining term is 1 by T1 minus 1 by T2 or log of K2 by K1 is equal to EA upon RT T2 minus T1 upon T1 into T2 or uh, convert this log into log base 10. So multiply this by 2.303. So we get log of K2 by K1 is equal to EA upon 2.303 R into T2 minus T1 upon T1 into T2. This equation is called Arrhenius equation. By using this equation, if we know the rate constant K2 at temperature T2 and rate constant K1 at temperature T1, we can calculate the activation energy. R is a gas constant, so we can calculate this activation energy. Or we can say that if we know K1, that is rate constant at temperature T1, uh, we also know activation energy and temperature T2, then we can calculate rate constant K2 at this temperature T2. Alternatively, the energy of activation EA can be calculated by writing the Arrhenius equation in the form of equation of a straight line. So equation 2 become, this is equation 2. Now write this equation in the form of a straight line, that is y is equal to mx plus c. So it becomes log of k is equal to minus ea upon rt plus log a. Now convert this log into log of base 10. 2.303 log k is equal to minus ea upon rt plus 2.303 log a. Now, log of k is equal to minus EA upon 2.303 RT plus log A. So, this equation becomes the equation in the form of a straight line. That is y is equal to mx plus c. Here, y is equal to log k. M is the slope, that is minus E upon 2.303 R. X is 1 by 3 plus C is log of A. Now, when we plot a graph between log of k versus 1 by t, then we get a negative slope having the value minus ea upon 2.303 r and intercept log of a. So slope is equal to minus ea upon 2.303 r. Thus, knowing the slope and gas constant r, activation energy, that is ea, can be calculated as, on solving this, ea is equal to minus 2.303 into r into slope. R is gas constant. When we plot a graph between log of k and 1 by t, then we get slope from this graph. So by finding the value of slope from this plot, we can calculate the activation energy. So this is all about the activation energy, and it's how it is calculated by using the Arrhenius equation. Thanks.